Hello, I welcome you all to this another interesting screencast. And the problem reads the uniform plate has a weight of 500 pounds. Determine the tension in each of the supporting cables. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a uniform plate that has a weight of 500. So we have been asked to determine the tension in each of the supporting cables. We have three cables. So what we are going to do now is to draw the free body diagram. So let's place the 500 pounds weight of the uniform plate at the center of gravity. And since this is a rectangular plate, it's very much easy to locate its centroid. So let's just draw these particular lines midway on either sides, on both sides, like so. So most likely it is going to be somewhere there. Let me use red so that it's distinct. All right, so it will be somewhere there. All right, so there we go. So this is where we are going to have our 500 pounds. Okay, so once we have that, let me just also just create some dotted lines like so that this does not distract. Right, and then we are going to section these cables. Okay, we'll section there, we'll section there, we'll section there. And once we've done the sectioning, then we'll have some tension force, and then let's call this tension B. We'll have some tension there, we call it B. We'll have some tension there, we call it B. We'll have some tension there, we call it B. And I mean not B, sorry, the other one is C. Sorry, this is C. There like so, this is C. And then there like so, this is A. And there like so, this is A. Great. Right, so we have three unknowns, and this is a 3D rigid body equilibrium problem. Okay, it's a 3D rigid body equilibrium problem, and in 3D we have 6 equations of equilibrium, right? Right, 6 summation of forces in the x, y, and z, and summation of moments in the x, y, and z. But in our case, since we have three unknowns, we just need minimum of 3 equations of equilibrium, right? We just need 3 equations of equilibrium to solve the 3 unknowns. Which unknowns are those? Tension A, B, and C. Great. Right. And we have them because I'm saying in 3D we have 6 equations of equilibrium. But we know 3 equations will not even be useful because we do not have any force applied in that direction or any reaction force. So we know that from this particular problem, we know that the summation of forces in the x is equal to the summation of forces in the y, which is equal to the summation of moments about the z-axis. This is all equal to 0. So the 3 equations are all equal to what? 0. Therefore, we remain with how many? We remain with 3. That will help us solve the unknowns. How many unknowns are there? 3 unknowns. Tension B, tension C. Great. So now, let's apply those equations of equilibrium. We'll start with the summation of forces in the z-axis equal to 0. That is the first equation. So what do we have? We have B, we have A plus B plus C minus 500 minus 200 equal to 0. This is the first equation, okay? Then we have another equation which is summation of moments about the x-axis equal to 0. Right. Which forces are going to cause moment about the x-axis? Tension C, tension A, and then with the weight 500 and the applied force 200. Right. So we are going to use the right hand thumb rule to determine the direction of moment. Okay. So for let's start with A. So A moment about it is clockwise. I mean it is going in this direction like this, right? So if you took your thumb like this, the thumb is pointing towards X. Okay, so that is a positive moment, right? Because it's in the positive direction of the x-axis and it's rotating like that. It will tend to rotate the body in that direction. So we'll say A times the lever arm. What's the lever arm? The lever arm is 3, okay? So that tension will cause a positive moment. What about C? C also it will cause the same positive moment, which is C times, what's the lever arm for C? For C also the lever arm is 3. Alright. Then what about the forces? I mean the 500, the weight, and the 200. They are going to cause the rotation like this, right? And when you look at that rotation, it tends to it's in this direction, right? It is moving in this direction like this, okay? So the thumb is going against the x-axis, right? The rotation is going in the negative direction of the x-axis, right? Therefore, both 500 and 200 will cause a negative moment, right? So we have minus 500 times the lever arm that is acting at half the length of the plate, this length here. Let me draw it properly. I think I draw it using like so. So that is the length, like so, like so. So let's indicate that one. That one is going to be equal to 1.5. Okay. So this 500 times 1.5, and then 200 also it will give us a minus 200 to give us a minus also, which is 200 times 3, okay, equal to 0. Great. And then what else? Then we have summation of moments about the y-axis. Okay, the y-axis we're using the thumb rule again. Which tension forces will cause a moment about y is B and C. Okay, so when you look at this B, it will tend to rotate like this, and that rotation is the thumb is going in the negative direction of the y-axis. So the tension B and C will cause a negative moment. So we'll have B times, what is the lever arm? The lever arm is 4, and C also, both these are negative, minus, and then the other one also is minus, and then C also, the lever arm is also 4, and then the other ones are going to cause positive, right? The active forces. So we'll have 500 times the lever arm is 2, that is about the y-axis, and then we have 200 also is causing a positive moment using the right hand thumb rule, and the lever arm is 2 equal to 0. So we have these sets of equations which we can now solve simultaneously, right? Great. So what we are going to do is we are going to make C subject of the formula. We are going to make C subject of the formula, and then you plug it here, and once you've done so, and then you plug it also there, and then solve these equations, right? So let's do that. So making C here subject to the formula, C is going to be equal to we have a 500 by 2 plus 200 by 2, that's 1400, then divided by 4, so we'll have a 315. All right, and then the other one is just going to be equal to minus B. So this is our C. So we are going to plug this C. We'll plug this C here. Okay, we're going to plug this C here. And once we've done so, then this expression will be in terms of B. All right, and we'll also plug this C there. All right, so that we have AB and AB expressions with AB and AB, and then we'll be able to later on solve them simultaneously. So let's get the first one. Let's find an expression from this one. So this one is going to give us, once we replace, we'll have 350 by 3, 350 by 3 minus 500 by 1.5 minus 200 by 3. So we have minus, so this gives us 3a plus 3a plus and 3 minus 3b, and then minus 300 equal to 0, right? Is that so? The C will multiply, the 3 will multiply by minus b, and then that's a minus b, and then the other 3 will multiply by 350. So 350 by 3 minus 500 by 1.5 minus 200 by 3. All right, so we have a minus 300. So we do the same also in the other part, this other equation. Let's do that also. We plug in, let's get the equation. What do we get? So C there, it's just a 350 minus 500 minus 200. So we have a minus 350. So we'll have an A there, and then we'll have minus B. There's a minus B there, so it cancels out. So this just becomes minus 350 equal to 0. And therefore, A is just going to be equal to 350. 350 what? What are the units? Pounds. All right. And we have 350. A, we found what A is. Let's find now what B is. Let's plug in this A. Let's plug in this A there. We plug in this A there. And once we do so, then we'll have a 3 times 350 minus 300. What does this give us? We have this, and then divided by 3. So we have B equals to 250 pounds. And once we have that, then we can plug in our B. We can plug in our B here. And once we do that, then we'll have a 350 minus 250. This gives us 100. Therefore, C is equal to 100 pounds. Great. So we have found what A is equal to. We said this is 350, and C is equal to 100 and B is equal to 250. So let's outline this, the final solution. We have A here, all right. We have B here, and finally we have C. Great. So this is really about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.